We're now going to use these sums to solve an applied problem. We're talking about free-falling space junk in space. So how do things fall in space? And so, for instance, we've had satellites floating around the Earth, and sometimes they get destroyed, and sometimes they run out of power, and sometimes we just stop using them. They become what we call space junk. And some of this space junk falls towards the Earth. Once an object begins a free fall to the Earth, it falls in a very specific pattern, which we'll show when we get to the problem. And so what we're going to do is we're going to look at a problem that talks about this. And so here's our sequence. The terms of the arithmetic sequence, 16, 48, 80, 112, and so on, give the number of feet that freely falling space junk falls in successive seconds. For this sequence, let's find the following. Let's find the common difference d. So we take the second one minus the first one. A2 minus A1 is 48 minus 16, which is 32. We check that. 32 plus 48, 10, 50, 60, 70, 80. So it works just great going from there to there. So now we know d. For part B, we want to know the nth term. So now that we know what d is, we also know that a1 is 16, so an is equal to 32 times n minus 1 plus 16. So there's our nth term. We found our general term. The distance a piece of space junk travels in 10 seconds. This is the partial sum Sn, or in particular S10. So this is going to be equal to, well, first we know what A1 is. We know that A1 is 16. A10 is 32 times 10 minus 1 plus 16. So we'll get out a calculator. 32 times 10 minus 1 is 9 plus 16 is 304. And now we can say that S10 is equal to 10 times 16 plus 304 divided by 2. This is 10 plus 10 times 320 divided by 2. I'm going to put the 2 into 120 because that's going to make it easier. 10 times 160. So it falls 1,600 feet in 10 seconds. The last part that we want to talk about is how much farther does it travel in the 11th through the 15th seconds. So here we're going to find A11, which is equal to, it's just 32 more than this, so we could use that, but I'm also going to show 32 times 11 minus 1 plus 16 is 32 times 10 plus 16, 320 plus 16, which is 336. A15 is 32 times 15 plus 1 plus 16, so 32 times 14 plus 16, which is, we'll get that calculator out again, 32 times 14 plus 16 is 464. And so there are 5 terms here between A11 and A15, so n equals 5, because you have to include both. And so we get that the sum from 11 to 15, I'm going to use some weird notation for a minute. This just is n, which is 5, times A11, which is 336, plus 464 divided by 2. 336 plus 464. 64 plus 36 is 100, so this is 800. So 5 times 800 over 2, which is 800 divided by 2 is 400, and 5 times 400 is 2,000. So in the 11th to 15th seconds, it falls another 2,000 feet. And that's how we can use these arithmetic sequences and their series to solve applied problems.